Continuation of the classification of systems. What are the major classification of systems? And before that, let us recap about a system. A system is a physical entity that performs an operation of the given signal, and it gives an output in response to the input signal. What are the major classification of systems? Systems are widely classified as linear and nonlinear, time-variant and time-invariant, static and dynamic, causal and non-causal, stable and unstable. These are the 5 major classifications of systems. What a linear system is? Linear system or linearity property shall be proved only with the combination of both superposition principle that includes homogeneity and addition. So what is addition? How it can be performed? We know very well addition shall be done only with the existence of two inputs or two signals. So if a signal x of t is given, then we have to decompose that x of t as x1 of t and x2 of t. So we have received two signals x1 of t and x2 of t. As per the concept, any input, once it is given to a system, it obviously gives an output. So x1 of t given to a system gives y1 of t. Similarly, x2 of t given to a system gives y2 of t. This is the input x1 of t and its output y1 of t. Respectively, x2 of t, its output is y2 of t. So keep this in mind first, right? Next is next comes the addition. Addition of those two signals. What is it? x1 of t plus x2 of t. So x1 of t plus x2 of t is the addition of two signals as shown here. x1 of t and x2 of t is the addition of two signals, and since linearity is not only with the addition, it also involves scaling. Every input signal is multiplied with the scalar quantity alpha and beta. Therefore, signal x1 of t is multiplied with the scalar quantity alpha, and x2 of t is multiplied with the scalar quantity beta. So the combined inputs alpha x1 of t plus beta x2 of t given to a system gives alpha y1 of t plus alpha y2 of t. So this is a linear system. It is given here, that is y of n is the system output using the input x1 of n. Similarly, y2 of n or y2 of t is the system output with the input x1 of t or x2 of n. So the linear system output due to weighted sum of inputs. So weights are nothing but the coefficients, that is alpha and beta are the weights or scalar quantities, which is equal to the weighted sum of individual outputs obtained from the corresponding inputs. That is y of n is equal to y1 of n plus y2 of n, whereas y1 of n is nothing but alpha x1 of n plus beta x2 of n. Here alpha and beta are the constant values. For example, we can understand the property of linearity with a small numerical problem. A digital amplifier is represented by y of n is equal to 10 u of n. So how this linearity can be checked? As per the principle or procedure, given input has to be decomposed as x1 of n and x2 of n. Right. So the x1 of n is equal to u of n and x2 of n is equal to del of n. What is y1 of n? y1 of n is equal to 10 times u of n and y2 of n is equal to 10 times del of n. Since the given input is decomposed as unit step and unit impulse. Right? So now we have to apply the linearity principle. Right? So x of n is equal to 2 times x1 of n plus 4 times x2 of n, which is equal to 2u of n and plus 4 del of n. So now the system output due to the combined input is equal to, as per the given problem, y of n is equal to 10x of n, which is equal to, substitute the value of x of n here, 2 times u of n is plus 4 times del of n, and therefore the answer is 20 u of n plus 40 del of n. If the weight sum is verified for individual outputs, let us see whether it matches with the previous answer. 2y1 of n plus 4y2 of n is equal to 20u of n plus 40 del n. So comparing those two equations, equation 1 and 2, which gives y of n is equal to 2y1 of n plus 4y2 of n. Therefore, since the equation 1 and equation 2 are similar or equal, the system is said to be a linear system. So always keep in mind that a system shall be confirmed as a linear system only if it obeys the principle of addition and homogeneity. Addition means we need two variables. Therefore, given input, single input shall be decomposed into a two input signals as x1 and x2, and based on that the addition shall be satisfied and along with the scaling. So if these two properties are followed exactly, that is considering the inputs and outputs separately and finally adding, that gives one answer. And again, considering an input itself is the addition of two signals, and also scaling property has been done on that input signal, then the output due to the weight sum of inputs is one answer. So we have to compare those two equations, and if both are similar, then the system is said to be a linear system. Else, if 1 is not equal to 2, then the system is confirmed as non-linear system. So this is a very interesting topic. As many problems we work out, we may get familiarized. Hope you understood this session. Thank you for listening. Thank you.